Hi, everyone loves soldering stuff here on the EEVblog. They're some of my most popular videos, my soldering tutorials. Well, today we're going to take a look at and review, I guess, play around with a Reflow oven controller kit from Beta Layout. They're a, oh, there it is. Comes in a huge box. They're a German company who started the PCB-Pool service almost 20 years ago now, where we take it for granted these days that there's lots of companies out there that will take your files and put them on a shared panel, and that's how we get our low-cost PCB manufacture these days. Well, they started it 20 odd years ago with PCB-Pool. They're one of the first companies to do it, and they're still going strong, and they offer this beautiful all-in-one starter kit for SMD Reflow, because they, as part of their PCB-Pool service, PCB prototype service, they offer a free SMD stencil with every board, and they've provided me, and they also sell this all-in-one kit. So we're going to check it out. It should be interesting. Let's go. Now, here's what I got in the box, and yes, my box cut does contain more than your usual box, but what is in the usual kit, just the Reflow soldering kit itself, is no, it's not a toaster oven, it's a Reflow oven. If you think it's a toaster oven, you're not thinking fourth dimensionally. It's from Sagan. I don't know, I've never heard of it. I don't even think you can buy it here in Australia. It's a European brand. I think we'll take a look at that, but we've got ourselves a oven with a nice clear door, and that comes with the Reflow kit, which we'll take a look at, which includes a multimeter and a whole bunch of stuff, and the paste and things like that. And just that kit alone is 129 euros for that, and or 178 US dollars. Now, also for another 129 euro, I've got the Reflow oven controller kit, which turns this toaster oven into a Reflow oven, all controlled, which we'll get into. But unfortunately, this is 240 volts only, so I don't believe they sell this in the US. So if you're in a 110 volt country, I think you are out of luck. It's not even on their American store. But anyway, so they're 129 euros each. I don't know how that translates into various countries in the European Union and stuff like that in terms of value. But yeah, you can probably get it. You can just buy this on its own. You can just buy the Reflow kit on its own, which is 91 US dollars. I'm not sure what it is in euros, and you can buy your own toaster oven. There's nothing particularly special about this toaster oven at all. You can pretty much use any one on the market, because as we'll see, the Reflow controller has a learn button on it, which basically learns and profiles itself based on the thermal oven that you've got. Hello, you can see me. There you go. This Sagan brand oven, you can buy this separately if you want. So you can just buy the Reflow kit, basics kit, and buy your own. If you can get this cheaper, then by all means do it. You don't necessarily have to buy it from Beta Layout, and it is just your typical direct heat toaster oven. It is not a convection oven, so there's no fan inside to actually circulate the hot air. They are technically better because they give you a more even temperature distribution with inside the thing. But this is just a crumb tray on the bottom here, so you don't even need that. Two elements on the bottom, front and back there, and there's another two elements on the top up under there. So there they are, up under there. So technically, the issue with these Reflow ovens is that technically you can get hot spots. Now, it's recommended that you have this in the center, of course, like this, but because there's no convection in there, there's no fan to blow the hot air around, technically you could get hot spots on your board, and that's not necessarily a good thing. So this is just a normal oven, but hey, it's going to be good enough, especially when you put the Reflow oven controller onto it. I probably wouldn't recommend a non-convection oven if you don't have a Reflow controller, but hey, everyone has their own experiences. I'm sure there are people will be saying, yeah, I got no problems using my non-convection oven without a controller, and it works just fine. But the issue with the thing with the controller is that, you know, you don't have to manually time anything or anything like that, and you know, it's going to give you a semi-professional sort of reflow profile. And control-wise, it's just a manual timer, which you're not going to use. And basically, whether or not you want the top elements, the bottom element, or dual elements, in this case, they recommend using the dual elements, top and bottom, so it heats it from the bottom of the board and heats it from the top. Try and heats it evenly. And then we've got our temperature, which goes from 100 up to 230. But basically, you want to just, for operation, because it's got the external controller, you just want to set it to maximum, dual element, and Bob's your uncle. Then the reflow controller does everything. It's got a temperature probe in there, and it actually can control the heating elements externally. So these reflow controller kits, they want, you know, you really need one of these dumb ovens. I mean, it doesn't even have a, you know, it's got an off switch, but, you know, you basically just want to leave the thing on. It's dumb. It's got no intelligent controller in it, so it can be, without being hacked at all, you can just put the controller in series with the mains plug, and it just switches the elements off and on, and can use the PID control loop to control the temperature inside once you put a temperature sensor in there. But as far as toaster ovens go, I don't mind the feel of this. It seems to be, you know, reasonable quality. Now, what you want in a good thermal reflow oven like this, nice big clear glass window so you can see exactly what's going on there. Absolutely essential for reflow work. It's got nice feet on the bottom of to lift it up above your bench, and it feels like a reasonable quality unit. You know, it's not high priced. It's probably like $50 retail or something, but yeah, it does feel decent quality. And it's got a total internal space of 300 millimeters across there. Easily fits my microcurrent panel, as you can see, and depth a good 300. So we're talking 300 by 300 millimeter boards. So that's a pretty decent capability. You probably, in most cases, don't want to do panels any bigger than that. And in our Reflow Starter Kit here, which you can buy separately, as I said, or you can buy the individual parts separately if you just need them. But this is all convenient in one box. It's got just 3M Scotch masking tape here to hold down the boards. We've got a power adapter, looks like a UK to EU power adapter or something like that. We've got ourselves our lead-free solder paste. This is about $20 retail or something like that. So that's 100 grams worth, so that's going to do a decent number of boards there, lead free. And we've got ourselves a spatula, metal spatula, that's going to work really well. We've got ourselves a cheap-ass PeakTech multimeter. Look at this pile of garbage. But, you know, they just throw this in just in case. Oh, something just fell on my toe. Oh, that hurt. That hurt. Oh, man, don't know what it was. Anyway, PeakTech multimeter manual range thing. They just throw this in. Oh, look, they've even got their own beta layout sticker on there. Look at that. And just some crap multimeter leads. No, there's the temperature probe, just in case you didn't have one. But there's also a temperature probe with the Reflow oven kit, which we'll take a look at. And inside, then we've just got some boards. We've got a training stainless steel stencil so that you can do some trial stuff on there, and then we've got various blank boards which you put down templates that you can just slide your board into and hold it in place with these angle pieces, as we'll see. Oops, I left these out of the box, but they do come with it. Last but certainly not least, they've got some example components, so various sizes, 1206 down to 0603, SOT 23s, and SO8 to match your training board, and some very nice looking Vitas brand Swiss SMD tweezers. Awesome. But this is where the real magic happens, the Reflow oven controller kit. So you just plug it in series with either this toaster oven or any toaster oven, and it turns it into an intelligent temperature profiled SMD thermal oven. Comes from Ireland. Awesome. So this one is, as I said, 129 euros, and it looks really good. Here's the temperature probe, which plugs into the front of this thing. Let's have a look. And this looks really top quality. You know, that's just really nicely done. I like that. It's got various preheat, soak, reflow modes, dwell, and a learn mode. As I said, you just press the learn button, as we'll see, and it learns the profile of your oven, sets it all up, and you plug your temperature probe in there, and mains power in, 240 volts only, as I said, mains power out, which then goes in series with the oven, and it's got RS-232 interface as well. And they did send me, where is it, a USB RS-232 converter, which I don't think comes with it. I think you have to buy that separately, or you can buy that from anywhere on eBay or anywhere else. And I thought I'd have to hack the weird-ass European plug on the toaster oven, but I don't. It comes with a nice adapter, which then just plugs into the back, and plug that straight into your toaster oven. Brilliant. And it looks like, assuming the serial number is sequential, they've made quite a few of these. 4,296, 1,500 watts max. This particular toaster oven is coincidentally 1,500 watts. And as I said, 230 volts only. So I don't believe they have a model yet. Maybe there's one in the works for the US market. But yeah, if you want 110 volts, sorry, this one's not going to do the business for you. And you know what we say here on the EEVblog, don't turn it on. Take it apart. If I can get it apart, let's see what this puppy has to offer inside. There we go. Oh, that's pretty neat. Nice little controller board. Looks like we have ourselves a big ass, yeah, we've got ourselves a big ass solid state relay down there from Sharp. By the looks of it, we'll have a good look at that. Nice little PCB mount transformer there from Girth. By the looks of it, it's fused, everything's hunky-dory. It's got an external fuse here, and that really looks quite neat. I rather like that. So yes, that is a Sharp 16 amp solid state relay S216SO2, 4 kilovolts isolation, mounted on a nice little heatsink there. That really is implemented quite nice. I rather like that. They've got a small HRC fuse down in here for that, and you know, it's just all nicely integrated, completely safe, not a problem. And we've got ourselves an AT-Mega 32 there, RS-232 interface chip, and a thermocouple amp, and that's all she wrote. Just down the bottom, just we've got a SO8 voltage reg there, and just the rectified AC input from the transformer. Too easy. And they also sent me an example of my latest microcurrent design board. They actually panelized this for me in a 2x2 format as an example of their PCB-Pool service. And the whole idea about the PCB-Pool service is that it comes with a free stainless steel stencil. So you get your board made and you get your free stencil, not a crappy Mylar one, but a proper stainless steel one like you get from a professional you know, SMD manufacturer for professional production. So that'll last for thousands and thousands of boards. Excellent. I love it. And yeah, their board quality looks quite good. They sent me green. That's their standard finish. They can do other colors and stuff like that to order, but they wanted to give me an example of their actual production, their regular production process. And as you can see, because I only gave them the single board file, they didn't know how to panelize this. I didn't tell them how to panelize it. So here's just a quick trap when you let a PCB manufacturer panelize your files for you. Now, if you compare it with the one that I did myself, you notice that they're in the corner like that. Because this is a front panel board, I deliberately specified in that, so when you cut it out with the side cutters, you get a nice clean, and all your edges are nice and clean and everything. But because I didn't tell them how to panelize it, just by default, they just whacked them anywhere. So they've put them in for me as this being a front panel in the most inconvenient location possible, which is on the side. So when you go and cut these things out, you're left with like a horrible looking side on them, and that's a lot worse than doing it on the corners. Now, you know, if you're doing a front panel like I am, that's really important, but if you're just doing a regular production board, regular board that, you know, goes inside a box and no one's ever going to see it, doesn't matter, of course. But I just wanted to point that out. That is a trap for young players about letting the PCB manufacturer panelize your board. And I talked about this on this morning's amp hour that I just recorded. So check that out. Now, normally I'm not a fan of green boards, but I actually really like it. It's more like an olive color when you've got of course, I've got a ground plane on top there. So, you know, here's the regular green because there's no copper under it. But you put that copper under it and it just goes this nice olive color. And I actually really like the standard green with the copper under it. That's just a beautiful color on it. And I can't find any manufacturing faults with this board at all. We'll take a look. I'll get the macro lens out, take a look in more detail. And there's the bottom of the flip side of that. They've just got it all right. We'll have a look at the via hole alignment and stuff like that. Let's go to the macro lens. Now, the first thing you notice is that this is clearly not a photo imageable overlay, component overlay, white component overlay. It's all, you know, dot matrix printed. And, you know, you can see that, yeah, you can see the lines in there and it just doesn't look nearly as good. You can see that, you know, the text doesn't turn out that great. So I certainly wouldn't use this as a production board, that's for sure, this particular process. So if you compare this, which I got from Project PCB, this is going to be my production panel. The quality of that is, you know, even though it is still that dot matrix technique, it's not photo imageable, it still, you know, is much better than the PCB-Pool one, unfortunately, which didn't turn out that great. So, but for prototypes, it's adequate. I don't really see any misalignment on those via holes either. So I think they're 0.4 millimeter on a 0.8 millimeter pad, not a problem. And no problems on the really thin slither of solder mask. I think that's like 4 thou or something going through there. Not an issue at all. So these PCB-Pool PCBs are perfectly adequate for prototype stuff, but the quality of their overlay does let them down significantly, I think. I'm not entirely happy with that. For prototypes, fine. Wouldn't touch them for production though. And the stainless steel stencil lines up perfectly, as you'd expect. Yeah, that's just me dicking around there. Unfortunately, they only gave me the stencil for a single board. They didn't give me the stencil for the entire 4-board panel. I'm not sure if that's usual or just that's a quirk of the one they sent me. So the issue with that, of course, is I can't reflow. Well, I can't assemble all of these boards and apply the paste like this, because if sure, I can line that up, use the squidgy, apply my paste on those pads, but then if I move it over to this one, it's just going to squish all the paste there. So what I'm going to have to do is break out the individual boards and just do them one by one. That's a bit of a bummer. I would have preferred to get the full stainless steel stencil for my entire panel. And by the way, it comes with an instruction manual on disc as well, so you can read this explaining how to do this and how to use the Reflow oven controller. Now, what I've done here is we're going to apply the solder paste. Let's get right into it. And basically this right angle board acts as a template. So you just stick that down there like as a template retainer. So you just stick that down in place like that, and then your board, which can just sit in, it just sits in the corner like that, and then you get one of these corner pieces and you tape it down. So when you're applying the squidgy across the top of that, once we put our stencil on, your board doesn't move. That's just the whole idea behind that. Now we want to put our stainless steel stencil on there, and there we go. It lines up perfectly. If you take a look at that, beautiful. There's a bit of art in getting these things lined up, but generally good enough by eye. Like that, and we only want to put one strip of tape along this edge here, so that when we're done with the squidgy, we just want to lift the flap up like that, so we don't, you know, dick around with it and disturb our nicely placed solder paste. So let's get ready to go. And let's have a look at the solder paste we're going to use here. It is AIM brand, which are one of the top brands in the industry. No clean, lead-free, tin-based solder paste. And it's important to get the no clean stuff. It means it doesn't leave behind any crappy residue that you've got to clean up on your board as a post-reflow process. So that's really good. Anyway, this is type NC254. That's the model number, SAC305. Don't confuse it with the NC254, which is you can get in a leaded version. This is the lead-free stuff. Looks like we've got a fair bit left on the expiry date there. This stuff, data sheet says it has a shelf life of 9 months if kept between 4 to 10 degrees C, or 4 months if left at room temperature. But for, just prototype dicking around like, we're doing here, you can probably keep this for 12 months at shelf temperature. It's probably still going to be used. You just mix it up a bit. It's just that the the volatile chemicals inside the solder flux in there just, over time just leak out or do whatever. They're just, but you can mix in some flux afterwards if it is like dried out a bit. But anyway, let's not go into that. So 100 grams worth, it'll do a decent amount of stuff. So this is what it looks like inside. There we go. 100 grams of solder paste. Tight asses. They can't give you a full tub, can they? Anyway, this comes in various type sizes from T3 to T5. T5 have smaller solder balls than T3. Comes in T3, T4, T5 are industry standard sizes. I don't see any T marking on there, so I'm not sure what size solder balls this particular one is. And here's the data sheet, which I'll link in down below, and it extols the virtues of this wonderful solder paste, a broad printing process window, and reduces voiding under micro BGAs. And there we go. This is important, 12 to 14 hour tack time. So when we apply our solder paste here to our stencil, we've got basically half a day of good working time to apply our components to the board, maybe 24 hours on the stencil. So, anyway, it's, you've in no hurry essentially to place all your components down. So that's really good when you're hand placing stuff. There's all sorts of printing recommendations here. Look at this, the squeegee pressure, stuff like that. But, when you're doing it by hand with your squeegee like this, I mean, obviously, not really controllable. But when you've got, as I've shown in a previous video, which I'll link in, when you've got automated squeegee machines, you can actually set and program all this sort of pressure and stroke speed into your machine. So you want to, there's all different types of solder paste. There's more on the market than you can poke a stick at, and you have to set up your solder paste machine in production to match the exact type of solder paste you're using. And there we go. There's all sorts of, the snap-off distance of your stencil and, separation distance. All sorts of stuff. They really go to town on how to use this stuff. And here's our all-important temperature reflow profile. And basically, the reason it looks funky like this is because they're basically the windows you have to operate in. So you've got to keep your temperature at each particular time point somewhere within inside this window. It's very broad down here with the preheat kind of stuff, doesn't really matter. But once it gets up to this critical region, you've got to keep it within inside that window to get optimum reflow soldering, then the cooling period. And that's why it's, it's best to get one of these reflow oven controllers. At least it's going to be repeatable and attempt to get a profile, even though we don't have a proper convection oven or a, proper IR oven or something like that. We've only got a toaster oven here, for goodness sake, but combine it with a reflow controller and we can get something that looks like one of these profiles. They've got one for low density boards and another profile for high density boards as well. And you'll notice that the temperature, there we go, it peaks around that 230 mark. And as you saw on the oven, this particular oven's only capable of 230, but it's going to do the job. That's just enough. And we have a visitor. Who is it? It's Sagan, and she who must be obeyed. Sagan wants to come in and play with the reflow oven. He's more interested in the MakerBot than the reflow controller. And there we go. There's the micron sizes for the little balls for the different types there, and you've got all the technical details you could possibly imagine, surface insulation resistance, and more sorts of stuff than you can poke a stick at. Look, tack test, test results and stuff like that. They've got various IPC standards for this sort of thing. And, well, surface mount reflow soldering is not easy, folks. It's almost rocket science. And, of course, all these thermal profiles, these aren't, absolute values. These can change depending on your type of components, your board, and things like that. Because if you've got some real critical components, you've got to watch out and make sure that your thermal profile is going to match those critical components as well. So here we go. I've got my stainless steel stencil just set there as a flap like that. So as I said, we can peel it off at the end, and we shouldn't disturb our solder. Now, let's get our paste out. We'll put a little bit on here. You've got to mix it after you get it in, and this can be tricky business. We won't need much, only need a tiny little bit today, so let's just put a little bit on there, and then we just want to have a play around with that, just give it a bit of a mix. There are better ways to mix it than this. Now if you're taking it out of the fridge, you do want to let it cool down to warm up to room temperature. But anyway, let's take that now and let's give it a go, shall we? We'll start like that and just move across like that. There we go, we've got some in there. And whoop, there we go. I probably should have done some more mixing than that. Probably a few people screaming at me at the moment that it's not optimum, but you want to get a bit of an angle on that. And I could have got that in one stroke if I knew what I was doing. Anyway, that looks pretty good. Well, good enough. Anyway, we'll just peel that back like that, and we should be left with a nice amount of paste on each pad. Let's go get a close-in look. There's our 0805 pads. Not absolutely perfect, but certainly good enough, and you can see the paste applied. There's our SOT 23s, our 1206s. 1206s, oh man, they're as big as houses. SO8, massive. No problems there at all, but there we go. We should be able to. And of course our little 0603s. Oh, that one down there is a bit of a loser, but that's got more than enough paste on there to do the job anyway. So that's just going to work fine. There you go. You can see that up close there. You can see, if you're watching this in HD, you can probably see the tiny little balls in that solder paste. And there's that little slightly failed 0603. We just SO8 over here. You'll find that there's a solder mask between pads. Alright, we'll place some parts. I've got some 5 SOT 23s here. We'll use the SMD tweezers that came with it. Personally, I don't like the hook type like this, but each to their own. We'll give it a go. And hand place. You don't have to get the alignment too spot on. Oh, they're all upside down, of course. And don't have to get the alignment too spot on, because the component will, when the solder paste reflows, they will self-center into the pads, and that's the beauty of SMD. You just got to get them near enough, and although it does vary with component. I'll place our 1206s here. These are, as I said, 1206s, big as houses. These things are absolutely enormous. Anyone who can't SMD solder using by hand using 1206 components really needs to get their eyes checked, because Stevie Wonder could hand solder 1206 parts. You want to give them just maybe a little push down there to get them onto the pads, and well, I'll finish the rest of them. Now, I don't care how good you claim to be, 0603 starts getting down into the territory of being a little bit annoying for hand soldering and hand placement. Certainly when we're talking hand soldering, I mean, I think I can solder 0603s not a problem by hand without any magnification. But then when you get to 0402, I find I really need magnification. It really helps. But 0603, generally pretty darn annoying, but that's what I got on my microcurrent. It wasn't designed for hand assembly. If I'm designing stuff for hand assembly, I'm going to stick to 05. I'm going to stick to 08, 05 and SO packages and SOT 23s. Now I've got my reflow controller hooked up in series with the oven here, and the soak LED is flashing there. That means that we haven't plugged in our temperature sensor. Now with the thermocouple here, we need a dummy board inside this chamber to get the heat from. Now it should be a similar material, similar type to what you intend to solder. So I've just got a standard 1.6mm FR4 board here. I've just thread the thermocouple wire through here just to give it some stability so it doesn't shake loose. And then I've just, of course you don't solder it in one of those holes, I've just placed it down in one of those holes. So we'll place this in the middle of our oven, and that will be our control board where this thermal reflow controller will learn the temperature from. So there we go, there's our board in the center of the rack. Now ordinarily I'd have this rack up a bit more in the center, but there's actually not an exact center point in here. But because I want to get some video, I need to have my board near the front of the edge down a bit. So I want to get some video through the glass here. So, you know, for production, you would want to put it in the center, but I'm going to do it over here. Anyway, it's hooked up. It's got it coming out the door. Now this is, you know, just a kludge at the moment. I might actually take the covers off this thing and see if I can feed in for a more permanent setup the thermocouple probe through the inner wall or something like that, and then have the board sort of, you know, semi-permanently set up in there. Now it's flashing. The learn LED is now flashing. That means that this box comes, well, dumb. It hasn't learned this oven. So we've got to put it into learn mode now, and it will just heat up the oven and it will learn. This is one of the things I really like about this oven. It'll check out the profile and set it up for any oven you choose. Really simple. I like it, assuming it works. All right, let's turn this thing on. Just goes through a sequence there, and the learning LED is flashing. So what we're going to, I've got my fluke hooked up as well with the thermocouple. Now this thing should heat up in learn mode, should heat up the oven to 100 degrees C so I can get a reference point and then stop. So let's press the learn button, and there we go. It's on. The light doesn't seem to come on, so I don't know. Is it? Oh yeah, no, sorry, it's on. You just can't see it. It's quite dim. Oh, I can see some smoke coming out, so this thing is probably to be expected, being used for the first time. Geez, I hope it doesn't set off the smoke alarm here in the building. That'd be embarrassing. And my fluke thermocouple isn't exactly on the board, so I expect some error there, certainly. All the residual smoke seems to have gone, not a problem. Oh, there we go. There we go. So according to the fluke, it overshot a bit, but as I said, that's not mounted on the board. It's not exactly going to be spot on there, but yep, that is done. It's finished. So now it's learned that it's not blinking anymore, so now we should just be able to run the soldering process, and it should work a treat. Now you can see that the reflow LED is flashing here, and what that indicates that inside the oven is still greater than 50 degrees Celsius, and it won't let you start a new soldering process until the oven gets down below 50 degrees. So that's one of the disadvantages with this thing, is that you do have to wait if you're doing boards, you know, big batches of boards in sort of, you know, a small scale production process. You've got to let the oven cool down to less than 50 degrees before you do your next board. So yeah, the rule of thumb is jam as many boards in there in one go as you can and reflow them all at once, because this could take some time to cool down. And of course, one of the reasons for the discrepancy on the fluke meter there is because the thermocouple of the fluke temperature probe there was just sitting in free air, so it didn't have like the thermal mass attached to the board like I've got for the other one in there. So you'd expect the fluke to actually go a bit higher than the 100 degrees C that the reflow controller was expecting. We're ready to go, so let's stick our board in. Once again, it shouldn't be at the front like this. I'm just doing this so that I can possibly get some video. So this is not ideal location because it's right under one of the elements here. Not that great a thing to do, but anyway, for the purposes of today's experiment and being on video, then that's what we're going to do. All right, we are ready to go. So let's run this thing. I'm trying to get a shot. I've only got the 0805s in shot here because I want to try and get the close-up. We should be able to see those resistors self-center though. So here we go. I'm going to press the solder button and, well, hopefully this sucker's going to work. Here we go. We're in our preheat phase, so this will take a bit. And this is designed to heat up the board slowly and evenly so that things don't crack, and the components so that things don't crack and do all sorts of nasty little mechanical issues. So we'll start out with the preheat, and then we'll go into the soaking phase, which is designed to activate the flux inside the solder paste, so that all the volatile chemicals inside the flux, they all burn out, and then you hit the reflow phase, wham, that just peaks it up and reflows that solder. And then after that we've got the dwell time, which is the actual decay of the temperature. So all these things, by the way, in this reflow controller, all these various parameters, they are settable. So you can actually program this all via the serial port. There's various serial port commands to do this, but I'm just using this straight out of the box using its default values. So who knows what's going to happen. But okay, we're up to a minute 10 and we're still preheating. There we go, we've just switched into the soak phase. My fluke says that was 118 degrees. And I can see that the element is switching off and on. It's switching the element off and on about once per second according to the blinking light on the front of the oven there. Sort of, or maybe, you know, half second on, half second off. Cycle time for that. So temperature slowly going up. It's still only 125 degrees according to my fluke. And there we go, we're into the reflow process at, well, 153 it's saying, according to my fluke there. And according to the oven light, it's the element is continuously on now, so we should see the temperature ramp up a bit quicker now. And the good thing about having one of these reflow controllers is that it does ramp up the temperature gently rather than just, you know, getting the regular toaster oven, just switching on the elements and, you know, baking your board. This one at least has a modicum of control about it. Here we go. You can see the solder starting to melt. And a couple of those, the ones on the left-hand side there, they've almost reflowed, but the ones on the right there haven't done so. They're about to. I think I can notice something happening there. So as you can see, not an even temperature spread across that board. And there we go, we've switched into our dwell cycle. And, well, we haven't had reflow of 3 of our resistors there. I can't quite see the other components, but I don't think they've fully reflowed either. So I'm not sure what the go is there. Anyway, it's still going. And we're back to a flashing reflow LED. I don't know. I might have to go read the manual on that one. What's going on? No, well, that, according to the manual as before, it's finished, but it didn't reflow all of our parts in there. It's terribly disappointing, and it didn't really pull them in place very well either, so this could be a fail, folks. So that is terribly disappointing, and of course I'm not going to touch it. It's still quite warm. In fact, these boards, as I've said in previous video, can retain their heat, especially if they've got lots of ground plane copper in them. This board doesn't, but still, it can retain heat for a significant amount of time. But we have a fail. I mean, these components, some of these components, just have not reflowed. I'll show you this when we take the board out, but yeah. What? This is supposed to work out of the box. And it doesn't. Disappointed. And as you can see, those SOT 23s haven't reflowed. I mean, some of the pins have there, but that's pretty much, well, it's certainly a fail. And the 0805s, as I said, a couple of them have reflowed, and they look okay. The 0603s have reflowed, not a problem there. And the 1206s, only a couple of them have reflowed, and our SO8 hasn't reflowed at all. And I just noticed something very dumb. I put the reflow controller up on the top of the oven here just for convenience for shooting this video, and of course the top of that oven is very hot, and consequently the bottom of that box is very hot as well. So I'm thinking that may have possibly affected the accuracy, perhaps, of the built-in thermocouple amp, perhaps. So that's probably not the best. You really don't want to be sitting this thing on the top of this reflow oven. Dull trap for young players. All right, let me try that again. I'm going to run through the learn process again and then run it through the complete cycle again with the board in the center. And this is the real advantage of the really smart learn mode on this thing. You can just, quickly just readjust it, recalibrate it for any position inside your oven. Or in changing ovens and things like that. I really quite like that. That works really well. And I started reflow soldering again. Sorry, I can't get any video of this. The board is like sitting smack bang in the middle of the oven and it's dark in there, so it doesn't really work getting a shot for these things. Quite difficult, but I can certainly see it by eye, but yeah, the camera's not that great. All right, we're in the soak phase now, and what we're looking for here is to at least, on our fluke here, for the internal temperature of that oven, to get at least to 225 or degrees or thereabouts, which puts it within inside of that reflow window there. Whoop, and we're into the reflow process now. And by the way, this LED on the front does actually match the heater element. So when that's on, it means the heater element's on, and the light on the front of the oven actually duplicates that. So if we don't see this get to at least like 220, 225, 230C, then, well, something's, out of whack, because I'm assuming that my a good fluke temperature probe is accurate. And even the chart that comes with the beta reflow kit, it's showing a peak at 250. This is for its supplied no clean lead-free solder paste. So in this reflow process, it says 2 degrees C per second ramp up. And are we 2 degrees C per second? Oh, not quite. Anyway, we're getting close to our temperature now. So this is pretty good. This looks like it's going to do the business. 220 is close enough. So I think we're going to be in the ballpark, and that board should have reflowed. It'd be nice if there was a light in there. Geez, that'd be neat. But it's still in the reflow phase. It's coming back down because it hasn't switched the heater on there for a bit. But it basically, according to our solder paste, our actual solder paste data sheet there, it got to 220, so it, it's pretty darn close to bloody fluke switched off. That's hopeless. And no, there we go. Oh, it's just switching it on again. So there we go. Oh, there we go. And we're in dwell now, but it's still switching that element on. But anyway, that should have reflowed. So I'm gonna claim that's near enough in terms of temperature. I'll probably get a second multimeter and a separate a second thermometer in there as well, just to check that out. But once again, but that's not the thermal mass though. Remember, this fluke temperature probe is actually just hanging in free air in there. So technically, that actually should be a higher temperature than what the oven is. But anyway, that is done. It is done and dusted. It is finished. So what did it peak at there? At about just over 220 or something like that. And the thing is, you can get in there with the serial commands and you can actually calibrate the thermocouple that comes with this thing. But it says in the manual, ordinarily you shouldn't need to do that. But there is a manual mode where you can go in and actually calibrate its temperature and pre-program it into here. There you go, that looks like it's done the job. If we have a look there seems to be some sort of like residual flux left over or something like that. So I don't know whether or not it's, surely it's fully activated. you're not going to get the solder reflowing unless that's fully activated, but I don't know this particular type of paste offhand and what it looks like after it's reflowed, but it barely got to temperature there. And well, yeah, I don't know. It looks like it's done the business, although I think we are running a little bit under temperature there on our oven, I think. I don't think it's getting up to exactly what it should be. So what I'm actually going to do, because I'm a bit concerned that this thing's a bit under temperature, I'm going to recalibrate the thermocouple in this thing. Now there's two ways to do it. One is to hook it up to a PC and do it that way, or it's built in to the firmware in here, and you can just do it like that. And I'll show you how to do it. I've got two other thermocouples, Agilent and Fluke, in there. As you can see, they're reading slightly different, so I'll just like split the difference or something. Temperature-wise, I think I'll probably, we'll get in up to like just barely 220 before. I'm going to set it maybe for 240 or thereabout. Alright, so the way I do this is I press the learn button, and as soon as the on-off button comes on, a LED comes on, I press the solder button, and then it'll turn the oven on full power. As soon as these two reach 240, I press off, and it should store the value in there. So here we go. Learn, and solder. There we go. Hello? Hello, McFly? It's not heating up. What's going on? And looky here, the two thermometers are eventually settled down pretty darn close to each other, so I'm pretty confident in that. What I've decided to do is hook on the serial port onto here and actually check, because it's got a command to check what the temperature's reading. So if we go into 28, to see if it matches 28. Here I am in the serial console for this thing. So if we type temp show, we expect to see, look, see, 36 degrees C. It's way out. No wonder it's reading, no wonder this thing was under. So this thing, it came out of the box was 36 degrees C. That's hopeless. That was why our board didn't reflow properly. It was too low in temperature because it thinks it's higher. If it's, if that was lower, then it'd go over temp, but it's not. It's higher than what it actually is in there, and well, no wonder. And if we actually type the show all command, it should give us all of the current parameters for this thing, and you can see that it's, the preheat temperature, preheat time, preheat power, soak temperatures, so all this stuff we can adjust manually if we want. Anyway, what we want to do is, because that's 35 degrees, it was 36 before, and it's 28 in there, we're basically out by 7 degrees. And if we go temp offset, then you can see that there's no offset programmed in, but we can temp offset, and we can put in -7. There we go. We've now adjusted that, and if we go temp show, it should give us 28 degrees. There we go. Spot on. Recalibrated. No worries. And I guess, folks, that is why they give you a multimeter and a separate thermometer with this thing. But how accurate it is, I don't know. I don't think it's going to be as good as my Fluke and my Agilent one. Well, let's try this cheap-ass multimeter, shall we? See what it tells us. 26. Not too bad. Only 1 degree C resolution, though. Alright, I've let it all settle down, and I've come back, well, the next day. Actually, it's the next morning, and 26 degrees C, so it's pretty darn close, and my Fluke and my Agilent probes are bang on to within 0.1 degrees, so I'm pretty confident with that. So what I'm now going to do is ramp up the temperature in the learning mode and just see if the temperature at a higher temperature thermocouple in there matches the multimeter. So let's give that a go. Got some capped on tape there, and I've got my Agilent thermocouple probe taped into a hole next to, so they're both making contact into holes next to each other on the board. So basically the same thermal mass. So we should be able to now track the temperature more accurately with our reference board in the oven with our Agilent meter. And you can see they're basically tracking pretty precisely now. I really like it. So I've got pretty darn good confidence with this thing now in terms of being able to actually track the real temperature. And also what I've got is the Bluetooth module connected to my Agilent meter here and the data logging app. So we'll be able to actually see profiles and stuff with our reference temperature thermometer. Beauty. So now what I'm doing is logging the temperature in learn mode, so we should see it go up to 100 degrees Celsius here, because that's what learn mode does. It goes to 100 degrees, it follows the ramp, it times it and all that sort of stuff, and it should switch off. We were well off before because we weren't connected to the same thermal mass. So here we go. So I got up to 135 degrees in learn mode and switched it off, and as you can see, it is slowly starting to just ramp back down now because the element's off. So there we go, we can actually see the ramp on that thing, and look at that. It's a really nice curve. I like that. I just read the instructions for this learn mode, and what it does is it once it reaches 100 degrees C, it actually switches off the element, and then what it does is it continues to track you know, and learn how long it overshoots basically over that 110 degrees or 100 degrees Celsius. So that's what it's effectively learning there, how much it overshoots when it switches the element off. So there's 100, where is it? There's 100 degrees there. So it switched it off. At that point, would have switched off the element there, and you can see that it's overshot. Ooh, like that. Ooh, I've zoomed in. There we go. But so it looks at that part of the curve there, and now it knows how much it overshoots. So I don't know, it applies it to some sort of intelligent algorithm, so it can now control the oven, presumably safely. So let's try this again in reflow mode. Alright, I'm going to start it again. I'm going to do the full temperature profile, and we'll see what we get, because all we care about is what's actually on the meter. So push the solder button, and here we go. Okay, so what I've done is I've set my reflow temperature to 230 degrees. Here I've actually programmed in that, so we should expect to get a maximum of 230 degrees C on here. So we're looking, and I can log the data with this serial command here as well. So I'll go, what I'll do is I'll go temp show and then 1 second, and what it does is it will, every second, it will just display new temperature there. So we can keep that running, and I'll start my login on the multimeter and on the login app, and I'll press solder, and away we go. As you can see, we've reached 240, 241 there, even though it's set to 230. So we have, you know, a significant amount of overshoot there. Not dangerous by any stretch. It's still within the, you know, the thermal reflow recommended profile of this thing. So that's not too bad, actually, especially given that, you know, this is a very small thermal mass board. So I'd be tempted to actually leave it at that. Because, you know, like components in my microcurrent, for example, are maximum recommended 250 degrees. So it's certainly under that. And when you put larger thermal mass boards in there, you'd expect a slightly lower temp. So I think that's pretty much ideal. Now it's still in the reflow stage, and it's still got the heater switched on. But what? No, there we go. It's just switching off and on now, and we're into dwell mode now, and we're continuing to log this thing. But yeah, I think that's pretty optimum. It didn't, it's not overshooting to dangerous levels. That's really all you care about, and one of the real dangers of not having a proper reflow controller on your oven. If you're just using the regular oven, oh, be careful. As you can see the profile there, and you can see the 3-stage step there, and that's exactly what they intended to do, and that's exactly what you need for the profile. So it's not bad at all. Now we're up to the 10-minute mark here now, and that is taking a long time to ramp down, so I haven't opened the door. So at this stage we probably want to, well, when it's actually done and goes beep, you probably want to open the door to ramp it down much quicker than that, because if you have a look at the recommended profile for the paste, I mean, you know, there's no way our little pissant oven here can A, ramp up that quick, and B, ramp down that quick as well. I mean, we're only talking, you know, 300 seconds there. So, you know, really probably best to just open the door at this point. So there you have it. There's the Beta layout reflow oven kit, and I really do like this controller. It works quite well, so I'm pretty happy with it. Very confident now with that thermal profile that the boards I whack in here will work, and no doubt you'll see future videos on this where I assemble the microcurrent and other boards as well. Oh look, it's Dickie Knee. Sorry, Australian joke. So you can get by with just a regular oven setting it to 230, doing timing. You can do similar thermal profiles to this to make sure it works and stuff like that, but I really like this controller. I think it's probably worth every cent. There's lots of other controllers on the market too. There's open source hardware ones and things like that, but yeah, this is quite neat. So pretty darn happy with this. I'll make a little dedicated location for this, and I've got myself a pretty useful thermal reflow oven now, which is, you know, pretty darn good. I mean, you know, it's not professional grade, but hey, you know, it can still do pretty decent quality boards in it without damaging components, because now I've thermally profiled it, know exactly what it's capable of. It's not going to go over temperature, it's not going to damage my parts. Can be pretty damn confident in it. Beauty. Catch you next time.